we all soup eaters.
Many people are utterly confused about quantum physics and where to begin. But it actually is not very difficult to understand. Today, I am going to discuss what it means and one property of it, the quantum superposition, in a way that you won't learn anywhere else. Quantum physics is a type of physics that most significantly followed by smaller particles called quantum particles, which are smaller than cells, atoms, protons, and neutrons we usually learn in school. They consisted of 17 kinds of quantum particles as shown. These particles are so strange that it exists in a state called a quantum superposition. But what does that mean? Here is the conventional definition of it. If you can't seem to understand how this works, I will visualize it with just a mobile fan. I will draw a dot on this fan and let us imagine that this dot is actually a quantum particle. When we turn the fan on, you cannot really see where the dots are, and the only thing we can deduce is the probability of its position, which in this case is around the circular path. Because of this uncertainty, we can make the first claim and say that they actually do not exist at one place, but at every place they could be at all at once. This is supported by the experiment-proven fact that light, or as we know in quantum physics as photons, a type of quantum particle, as many physicists would say, behaves both as waves and as particles. This happens because when we do not use a detector to detect where the photon is, we cannot know where it is, and at that point it will behave as waves, which is also translatable to the arrays of uncertainties with the area with higher probabilities of the particles being there, behaving like the peak of the wave, and the area with smaller probability behaving as the base of the wave. The freakiest thing about quantum superposition, however, is that the quantum particle can either behave as wave, or as we know, arrays of probability, when they are not being detected, but when they are, they will be just a particle with a definite location. So how can this happen? The fan can be used to explain this as well. Now let's say we hold on to the fan. By doing that, it is basically like taking a detector to determine where the particle is at that instant. The only probability of where the dots would be is only at this point. Since quantum particles can and will exist everywhere that they could possibly be all at one time, as suggested by our first claim, when the only probability of where the quantum particles can be is at one point, it is only at this point and can't be anywhere else but this point. But when you let go of the fan again, the uncertainty starts to spread. When you slightly let go of the fan, the areas of probability where the particles can be get larger, so they are everywhere in these smaller areas. And when the fan spins even more, the possible area that the particles can exist at a single moment expands, and that area will get larger until it cannot get any larger. This means we can suggest the second claim that quantum particles will exist as particles only when their location is observed at a given moment in time. But as soon as we are not observing it, the more it will behave as waves as time passes, like they regularly do. Thank you.